Hello, this is Mr. Taylor with Young Engineers of Today. We're going to be beginning our introductory presentation on materials engineering. This presentation has been supported by and brought to you by Young Engineers of Today and the American Ceramic Society. First thing we're looking at is this new, almost hybrid metal, liquid metal. It's twice as strong as titanium, very resistant to scratches, very resistant to dents. This video, if you start on 1 minute and 5 seconds in, using the YouTube video link here from Modern Marvels, it goes much more detail for about 3 minutes. So please take the time to stop and watch this. Pause this video and then go to that link and watch this. Thank you. All right. The next new material that's just amazing is graphene. Graphene is the strongest material ever made, 100 times stronger than steel, stiffest, thinnest than we can even imagine. It almost seems like something out of a comic book. Graphene is the next big but thin thing. Please use the YouTube video link here and watch this. Pause this video and go back to that. Thank you. The thing is, with graphene, the uses are limited so far. We haven't got to the stage where manufacturing, being able to use it on a large scale, has put the research or time into to drop the cost. All right. One thing is to discover something. The other point of this is to altogether manufacture it. You can discover and invent, but if you cannot manufacture on a large scale to get the cost down, it can't reach the masses. A great quote to identify this is, the more innovative, the more breaking the mold the innovation is, the less likely we are to figure out what it is really going to be used for. There's a large quantity of technologies and discoveries, etc., that have basically sat on the shelf until the research and development and cost-cutting procedures put into manufacturing have made it accessible to everyone and useful. All right, restricting adaptations in the marketplace, or why don't I see this wonderful stuff in stores? You have to be able to make it, and not just make it one by hand. It has to be better or cheaper than existing products. And we can look at this, for example, silicon. 100 years between the discovery and then the use of silicon chips. Silicon chips are used in everything. It's a great conductor and regulator with heat for within electronics. But it took a lot of time and research and development money to get it to the point where it could be mass produced through manufacturing. Aluminum is another great example. 1850 discovery. It was extremely expensive. It was pretty much used as jewelry. Think about aluminum being used in jewelry. We don't even think of anything like that now. In 1880s, it was started being mass produced. That took 30 years there. Think about that. And then it was another almost 40 years until it started being massively used in airplane bodies. And then now think about it. We can't go our day-to-day without seeing a piece of aluminum. It's everywhere. It's really dropped the cost. Another example of this is with gasoline. Gasoline was used after the discovery of oil through Drake's Well. We're talking around 1830s, Pennsylvania. In the process, the primary thing people were using it was crude oil, was to get to kerosene. Kerosene was very stable. It burned at a equal level that you could contain. It was used for light. In the process of taking crude oil to get kerosene, one of the runoffs and things you'd make along the way was gasoline. And they were just pouring it out. No one knew what to use it for until the creation of the car. And then the mass production of the car by Henry Ford and others in around 1910 to 1920, etc., and onward, then you start seeing gasoline finally having a purpose. So there's a lot of things that are discovered and created and used, but not until it's able to be mass produced or manufactured or have a place for it. So what is material science? Material science is the study of solid matter. It investigates the relationship between the atomic or molecular structure of material and its micro and macroscopic properties. Micro meaning cannot be seen with the naked eye. It's too small. Microscopic, it's small, but it can still be seen with the naked eye. Examining and understanding what influences the properties of materials so that the right material can be selected for a particular application. Everything that we use and come in contact with today has gone through some type of process like this. They're always examining, trying to see what materials can be used for and the best use of them. Material typically falls into one of four classes: ceramics, metals, polymers, and composites. And we're going to look at all four of these. What is a ceramic? It's an inorganic, non-metallic solid created through heating and then cooling. What are some unique properties of ceramics? Ceramics are generally brittle, hard and strong in compression, but not other types of loads. Does well with compression, which is a pushing force, but doesn't do well, for example, with tension, which is a pulling force. They're generally better at withstanding corrosive environments and high temperatures. This is why we use these items as with cooking and baking. You can put them in an oven, and they can handle heat very well. And the common ceramic materials are silica, sand, alumina, Corning ware, and porcelain. Here's some examples in the images. You probably have those in your kitchen. What is metal? Elements are compounds that have good electrical and thermal conductivity. What are some unique properties of metals? Metals are metallically bonded, and therefore their outer electrons can easily be removed. They're generally malleable and ductile. Malleable means to be shaped. Ductile means to be turned into wire, and have higher densities than non-metals. What are some common metal materials? Elements: iron, copper, gold, silver, and tin. Some alloys are steel and nitinol. The thing that's wonderful about metals is that they're used in our electronics, they're used in housing and construction, roads, wiring. I mean, they're everywhere because of these properties. They're an amazing resource that we have. Polymers. They're chemically compound with a structure of many repeating subunits, often called monomers. What are some unique properties? They tend to form glasses and semi-crystalline structures rather than crystalline structures. Polymers are strong, flexible, non-reactive, moldable. Here are some common ones. Polyvinyl chloride, PVC pipe. Probably have this in your house, in your plumbing. Wool, shellac, rubber, and nylon. Nylon and wool used in clothing. Now, what is a composite? A material created from combination of two or more different materials. For example, Portland cement plus water plus fine aggregate sand plus coarse aggregate gravel equals concrete. What are some unique properties of these composites? Composites exhibit characteristics different from the characteristics of the individual materials, meaning all the four above materials have different qualities and characteristics, but when they are combined, they make something different. Now, properties can be tailored for a specific application by changing the amount of individual materials included. For example, if I add more water or more sand or more gravel or more Portland cement, it will change what my concrete's going to be like. I can make it softer, I can make it harder, I can change the process of it and its characteristics. Now, what are some common composites? Concrete, obviously, we just talked about that. A natural one is wood. It's made of cellulose fiber cells that are held together with a natural glue called lignin. Tires, composed of rubber and one or more types of fibers. Rubber holds the air in while the fibers withstand the stress imposed on the tire as the car is being driven. If you've ever been on a tire swing or seen an old tire, you know exactly what I'm talking about. Now, glass. Real-world application. Glass can be heated to a molten mold into many different shapes, from the vases to sheets of colored glass for stained glass, as we can see here. Windows, introduction of different ions during the heating process can yield glass in different colors. Okay? Now, we have two videos here. Please use these links. They're total of about 20 minutes. First one is roughly a little over 9, and the second one's a little roughly over 10 minutes. These are brought to you by Corning Glass Education info. They're hosted by the Mythbuster guys, and it's just a great example of materials engineering and some exciting tests. And it talks about the process of how glass has constantly been improved over the ages, and we keep learning more and improving the skill sets in the manufacturing of glass. Now, the other thing we did, if we finished early, just a reminder, please get your checkers done. If you have not done so, and this is the way you post them on there, and then you can always continue working on Code Combat. All right, this is Mr. Taylor with Young Engineers Today. Thank you, and take care.